So the hard part in this question is to figure out the general expression for the number of organisms on the nth day. So I'll just call the number of organisms on the first day to be a sub 1. I know it's 2, but I'll leave it in terms of a1. So if I were to write out the subsequent terms, a sub 2, the second term would be 3 more than twice that, so 2a1 plus 3. And I can repeat that. A3 would be 2a2 plus 3, and if I plug it back in, this would be 2a1 plus 3. I'm doubling that, plus 3, so that becomes 2 square a1 plus 2 to the 1 times 3 plus 3. And I'll keep doing it until I see a pattern. So again, I have to double that, add 3 to it, so this would be 2 cube, 2 square, and then 2 to the 1. And so you'll start to see the pattern. That is, the nth term would be 2 to the power n minus 1 a1, 2 to the n minus 2, 3, 2 to the n minus 3, 3, and then so on and so forth. So that's our nth term. Now you'll note these all have this multiple of 3, so if I factor it, you'll get a geometric series inside. And sometimes I remember this formula, but sometimes I like to just do it again from scratch on the exam. I don't know, that's just me. And the way you do this is multiply by the common ratio, which is 2, so double it. So this would become 2 to the n minus 1, n minus 2, and then 2 square plus 2, and then you subtract, you get x, because this is 2x and that's x. These terms will all drop out from here to 2n minus 2, and you'll end up with that. And yeah, there is a formula to do this, but as I said, sometimes I just prefer to do that. So we're here. So that's our nth term. I can collect those two terms. Then it would be a1 plus 3 and then minus 3. So that's my nth term. And you can check this one. I mean, I will, of course, in the exam, a2 would be twice that. So that would be 2 times 2, 4, so 7. a3, 17, double that, add 3. a4, double it, 34 plus 3, 37. And we can check a4. I would definitely do that in the exam. a1 is 2. So 8 times 5 is 40, minus 3 is 37, so it does match. Because you don't want to make a mistake at this point. And then our condition, a1 is 2. Now I can add that here. We need this to exceed 1 million. So 6 zeros. Since we'll be adding 3 to both sides, we can kind of ignore that because that's pretty small compared to 1 million. And I just have to divide both sides by 5. 200,000. And here, if you were to, and so of course with the calculator we are constrained, so we know 2 to the 6 is 64. If you do 2 to the 6 3 times, 64, 64, you'll see that that number will be higher than just the next higher number. It's, I think, 260,000 something. And so we know that n minus 1, when it's 18, that's when I would satisfy this condition. That means n needs to be 18. And you can think of it, if you plug n to be 19, you will find that that is the first time when it exceeds 200,000. So the answer is 19. But yeah, this is a difficult question. I don't know if there's another way to do it. Maybe the brute force, perhaps. I'm not sure. You could just keep writing out the nth term, and since you know that you only have to go to 19, it's not too bad. But the answer could have been 43rd. So of course, you know, that would be the difficult part. But I'll probably skip this question in the exam. Or if I had time, I might attempt it at the very end. But yeah, this is a difficult question.